What a crock. Anyway, go ahead. What's that? No. Even if I did, I wouldn't be able to give it. I would talk.
Why would you tell yourself?
Because I wouldn't be able to hold on to that guilt.
Guilt of what?
Of giving you something that I wasn't allowed to.
Like Advil?
Yeah.
That's dumb.
Well, the guilt would eat me alive.
The guilt
of breaking the rules.
Mr. Murphy, you look like in high school like you were an athlete.
Thank you?
Would you
Question mark?
Did you play any sports?
Yeah, did you pay attention to the Markey quiz at the beginning of the year?
Who's on the math team?
The math team.
I don't remember that question, so I want to know what sport.
Oh wait, yeah.
I did football, baseball, and bowling. Yeah.
Did you hit the
I do football, bowling, and volleyball.
All right.
What's the show on your way?
No. Anyway, back to this. Ladies and gentlemen, couple of reminders. You do have a major assessment that is due. I made it due tomorrow. I originally was going to make it due Friday, and then I wanted to give you guys a little extra time. So it is due tomorrow at 2 p.m. Oh, I got you. Ryan, I got your message. I read it this morning. I'll be able to reply to you after class. So just to make sure you hear that. There's someone in the chat. Don't worry about it. But it's different Ryan. But yeah, I'll be able to reply to you after class once I have an opportunity to sit down and type out that email. But anyway, yes, it is due tomorrow at 2 p.m. So you have the time to get that done. Several of you have already gotten it done. Thank you. Fantastic. Wonderful. Yeah, and we'll talk about that when we get there. Now, as for today and as for next week, has anyone told you what's going on next week?
What?
Yeah. Yes. Yeah. 7. Okay, let me explain that. Thursday is the last day right before spring break, and I'm going to say this very deliberately. Thursday is supposed to be a half day. However, you already have half days. You will be out by 11:40, and the benefit of that day is that teachers can leave by 11:40. Woo! That's a debated topic, but we'll talk about that another day. Anyway, but yes, next week you do have benchmarks. Now, our benchmark is scheduled for that Thursday, just so you know. I know. This has been such a stinking hot debated topic. I got to tell you, and this is not on you guys. This is the data that is collected from these benchmarks has been scrutinized and overanalyzed by people above teachers' pay grades to the nth degree, to the point where crap has continued rolling downhill onto us. And I'm like, well, number one, the benchmark doesn't count against you. Number two, there's a ton of information on the benchmark that is not even taught in this subject. So, but you're telling us we need to score better on these benchmarks. Yeah. Good.
How much benchmarks do we usually take in school?
No. Maybe. I don't know. See, the thing is, you know what it is? You know what it comes down to? Do you know what it comes down to? The school used to do, hold on, I'll explain exactly what happened. The school used to do this stuff on that website, Edulastic, which is why I like that website, Edulastic. I really do. But they switched over their contract. They ended their contract with Edulastic, and they began a contract with that website, Linkit. And when a school district enters into a contract with a website like that, obviously it's a bit of money, and they want to make their money worth it, and they want to make it justified that they're using the money in such a way. Because Linkit offers all of this data analysis. Notice the sarcasm in my voice. So as a result, they want to get their money out of it. So we do benchmarks on Linkit. We do midterms on Linkit. We're going to do finals on Linkit. Everything's Linkit. Again, notice the sarcasm. Yeah. Maybe. So what it comes down to, next week we are taking the benchmark. Yes, it does not count against you, but as always, we do ask that you do put in your full effort to get that thing done. I don't want, well, 95% still better than what some people give, you know, but what we don't want is just people blowing through these questions and just be like, da, 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 abacadabra, you know abacadabra? Yeah. Abacadabra is made up of letters A, B, C, and D. Okay. Nice. Who's that? Okay, that's fine. Oh, abacadabra is how some people fill out multiple choice questions. No.
Yeah, that's what I heard.
No.
Scientifically, C is most often the correct answer.
No.
So what is it?
It doesn't make sense.
It's a 25% chance for every one.
Yeah,
Yeah, but
If there's 4, if there are 5 options, it's a 20% chance.
yeah. However, but they're always on a test. There's going to be one answer that is more often the right one.
Well, sure, just like if I flip a coin 10 times and I get 6 tails, there's nothing out of the ordinary. That's just natural sampling variation.
But what if it's not random?
It is,
So
But how do you know?
what if
because I know.
But did you make it?
For the most part, yeah.
The benchmark?
Yeah, well, not the benchmark, but yeah. Huh. So anyway, next week we're taking the benchmark. Haha, thank you. So, what we are going to be doing today is going to set us up for the next chapter. It's not that I'm officially introducing the next chapter right now, but I would like to set you up for the next chapter. I'm not assigning anything for the next chapter. I just want to reintroduce you to what we need to do for this upcoming chapter because it is such a huge deal. Again, the majors due on Saturday. I have begun going through your projects. If you have not turned in that project, I need that to be done. I have begun going through them and grading them, as some of you have gotten your grades back for that. But yeah, today I would like to reintroduce you to this topic, and then I would like to wrap it up if the time suffices. I would like to wrap it up with the quizzes. But as for now, if you do not already have them out, I'm going to need those notebooks out and open. Look at the screen. There we go. Boom. Up there. Electric. Okay. Early on in this school year, we did a deep dive into factoring quadratics. Factoring quadratics was a skill that we needed not only in that chapter of quadratics, but we also needed it in the following chapter, which covered factoring polynomials. This is going to be a reintroduction to factoring. Now, I want to show you a few visual examples. As to what we will ultimately be doing during this chapter, but I want to make sure that you get that down and understand this is what we need to start with. During this chapter, this brand new chapter that we are about to embark in, there are going to be some problems which simply tell you to simplify, but in order to simplify them, you need to be able to factor first. There are going to be some problems that ask you to solve with these messed up problems that I am about to kind of give you a visual representation of. But in order to solve them, you would need to factor first. And then ultimately, we are going to be able to graph some of the messed up equations that you are going to see during this chapter. But in order to graph them properly, you're going to have to factor first. I need to reintroduce you to the concept of factoring.
Why do we not do all of one topic at one time?
You'll understand once I show you the visual. I'm going to go to my calculator. I'm going to type in an equation. Clear that. I'm going to type an equation into the y equals k. Now I'm going to show it to you both on the computer calculator and my 83 calculator, just because I want to show you what the heck's going on here. But on the top of the fraction, I'm going to do something like x plus, come on, that's not an x, that's an arrow key. X plus, give me a number, 5. And on the bottom, I'm going to do x minus, give me another number, 2. Oh, and I got to put something in between there. Insert a division symbol. There we go. So look at that. What I have on the board right here is just a couple of basic binomials. Binomials that could result from the idea of factoring, but I decided just to kind of show you this first. But this is what the thing typically looks like. Y equals. Now, I'm going to show you a few different examples here. This is the first visual example you're going to see of this. So brace yourself just for a moment. Brace yourself. Graph. Look what you got here. What does this look like to you besides hot garbage? Maybe. What'd you say? He said a skinny waist, but I'm going to go with something else. Maybe. Oh, like the stitches on a baseball? I see what you're saying. Yeah. Why'd you come up with that? We're in a baseball. Is that not? I don't even know if that's a baseball hat. I have no idea. Okay. Now, in the past, you've graphed lines. You've graphed curves. You've graphed parabolas. You've graphed cubics. You've graphed square root functions. You've graphed exponentials. How many equations do I have written here? No, just one. This is one whole equation. How many separate curves do you see here? 2 separate curves. Think about that. These are 2 separate, distinct curves made from one equation. I'm about to mess with your heads. Watch what's going to pop up next. Let's see what we got here. I'm going to change something about this. I'm going to change the bottom of this fraction, and I'm going to change it to be x squared minus 4. Check this out. I just changed one little thing about that equation. I kept the top of it the same. It's now y equals x plus 5, when the bottom, it's an x squared minus 4. Now, on the bottom, you have a quadratic. And on the bottom, with that quadratic, you could factor it. Factoring it will lead you to some interesting pieces of information, which we will get into before the end of this chapter. There's a big chapter we got coming up. But let me just show you. Now, mind you, I mentioned simplifying, I mentioned solving, and I mentioned graphing. Graphing is probably one of the latter things that we're going to end up doing during this chapter. But watch what the heck happens when I click graph here. Yes, that is the reaction I expected. One equation, 3 distinct curves. What the heck is going on here? Is that what it looks like? Is that a Minecraft reference? All right, whatever.
It was one equation
Mhm.
When it was x minus 2 and it made two curves, then you made the bottom one an x squared. And
Can I mess with your head some more? I'm gonna do something very simple. Very, very simple. This equation, I'm just gonna turn it upside down. That's all I'm gonna do. So I'm not gonna change any of the variables. I'm not gonna change any of the numbers. What I'm simply gonna do is I'm gonna retype this thing, but I'm gonna make it as x squared minus 4 divided by parentheses x plus 5. That's not an x, that's an arrow. X plus 5, there we go. You ready? Graph.
that was a nice split.
Kinda. Now it's this little swoosh thing. See, the funny thing is, this isn't even the whole graph. This isn't even the whole graph. This is x squared minus 4 over x plus 5. Let me change the size of my window so I can show you what I mean. You're like, what do you mean that's not the whole graph? Hold on. Change the size of the window. Let's go negative 50. Nope, that's not a negative. That is a point. Negative 50. Graph. Come on, where's the other half of my graph here? Let's change the y min to be negative 50 as well. Graph. There it is. Found it. I found it. It's so messed up. See, here's the thing. Back in Algebra 1, you guys mainly studied straight lines, correct? What does real life have to do with straight lines? What's more true to life are parabolas. Well, so to speak, but what's more true to life are parabolas. Like if you throw an object, it follows typically a parabolic path. Fair? You know? But still, it would follow that perfect parabolic path if there was no gravity and I'm sorry, not no gravity, if there was no friction in the air. Have you guys learned in physics how objects when they pass, they obviously they follow the rules of gravity, but then there's forces kind of pushing against it and with it and stuff like that? All right. I'm just saying, I don't know, is that physics?
Yeah, I think that's we learned that in bio. I think it's kind of like an intro to physics.
Okay, I gotcha. Well, real life is not a straight line. Real life doesn't follow a perfect parabolic path, If you think about it, if I have to fire a missile from New York to Los Angeles, maybe not, I shouldn't say missile. Maybe I should just say fly an airplane, whatever. I know. It's still not even a perfect parabolic path, It's more elliptical, so to speak. But these graphs that we're going to be studying during the course of this chapter, these are really going to mess with your heads a bit more. Now, I want to show you something on my graphing calculator. My graphing calculator does not have the proper ability to display these graphs. My graphing calculator kind of gives up halfway through. Check this out. Let me reset this. And the first one we did was x plus 5 over x minus 2. Check this out. My calculator kind of gives up a little bit right in the middle. Look at this. Look at that. This is the first graph I showed you. Except this graph has something extra. What is that extra piece? Yeah. No. That's a very good question. They're not connected. Well, the thing is, there's not supposed to be a line. There's not supposed to be a line. X plus 5 divided by x minus, no, again, I did the thing with the arrow. X minus 2. This is what it's supposed to look like. Oh, hold on. Zoom 6. There we go. That's what it's supposed to look like. And this is what my calculator says. Hey, in exponentials, when we covered exponentials, we talked about this invisible barrier that the graph would approach but never cross. Do you remember what we called them? Started with an A. Asymptote.
Oh, yeah. Oh, my. I literally, the second you went to say it, it popped in my head. It was
For exponentials, we dealt with what was called a horizontal asymptote, a barrier that the graph would approach but never cross. With these problems, they also have a form of a horizontal asymptote, but they also have a form of a vertical asymptote. This is going to get messed up. I'm so excited. Now, this was just a small visual preview. I'm not expecting you to graph these like today. No, I'm not expecting you to graph these today. Instead, what I titled this very much on purpose. Come on, get back to the right screen. Oh, it's right here. Zoom out. I called this a reintroduction to factoring because in order to do anything in this chapter, you have to be able to factor anything through greatest common factor, through quadratic factoring, through higher level factoring. To remind you, the higher level factoring, do you remember when we did, I'll see if you can remember this because you couldn't remember asymptote, but do you remember what we called those bars? That's going to come back as well. It was for polynomial division, yes, called synthetic bars. They're going to come back in a big way as well. So let me reintroduce you to some concepts of factoring. First and foremost, the most basic concept of factoring is GCF. GCF, of course, if I were to ask you, you would immediately be able to say to me what? Yay, we did it. Greatest common factor. An example of greatest common factor would be something like this. 2x plus 6. If I were to say what is the greatest common factor of that expression, you would tell me what? Say it louder. 2, yeah, it's just 2. They both have a 2 in common. 2x you could divide by 2. The 6 you could divide by 2. Thus, you could take that 2 out, and now it is factored. Factoring is the idea of breaking things apart to their prime components. It's something that we have done in the past. That's just an example of greatest common factor. Here's another example. What was that? What was another example of greatest common factor? Let's say, look at that quadratic floating around there. What would be the greatest common factor of that expression? Yeah, they both have an x in common. And since they both have an x in common, I can take out that x as a greatest common factor, dividing each of those terms by x, leaving me with an x plus 3. Notice I did the same thing twice. I did the exact same thing twice. It's just in the first one, I made the GCF a 2, and in the second one, I made the GCF an x. But both of these expressions are almost identical. It's just because of what the GCF was, it changed the way that it looked. One general idea of factoring is greatest common factor. You have to look at all of the terms to be able to take something out. So one more of this for greatest common factor. Let's say I had x squared plus 2x plus 6. What is the greatest common factor? Unfortunately, no, because they don't all have an x in common. Two of them have an x in common, and 2 of them have a 2 in common, but not all 3 have the same thing in common other than 1. 1 is the only thing that they all have in common. So I can't take anything out. I can't take anything out. If your GCF is 1, you can't take out a GCF. And then you would have to move on to other forms of factoring if they were possible. This one's technically done. That's all we can do. Now, I would like to introduce to you another step in factoring that we took very early on in the school year. I want to reintroduce you to the Tucker method. Now, some people may have liked the Tucker method. Some people may have used other methods. That's perfectly fine. But you need to be able to do some form of quadratic factoring. Some form of quadratic factoring. I want to rewrite the steps of the Tucker method, and then I want to actually put them into practice. There were 5 basic steps to the Tucker method. Now, for the Tucker method, again, this is for quadratics in the following form: ax squared plus bx plus c. This is a huge reminder as to what we did in the beginning of the school year, and you are going to need the skills of factoring quadratics to be able to survive this chapter. GCF is one of those skills. The first step of the Tucker method is nothing more than taking out your GCF, your greatest common factor. That is the first step of the Tucker method. But sometimes you can go farther. Sometimes you can go farther. And if you can go farther with this Tucker method, then yes, you absolutely should. The next step of this Tucker method was to multiply together the letters of A and C. And if you notice right here, kind of put those together, there's your A times C. That's where your A comes from. That's where your C comes from. They are numbers. They're not going to be variables. They're going to be numbers, the coefficients. After we multiplied together the numbers A times C, we would get a value, some kind of a value. And that value is what we would have to use for step 3. Step 3, if you happen to remember, we're finding your magic numbers. You had to find 2 numbers, 2 magic numbers that multiply to AC and add to the value of B. They have to multiply to A times C, and they have to add up to the value of B. They have to do both at the same time. That's why they are magic numbers. If you can find 2 magic numbers that work, then you can continue and actually try to factor it. Let me ask you this question, though. What if you couldn't find 2 numbers that worked? What if no such numbers worked? Ooh. Can you think of 2 numbers that multiply to 17, but you can't use the number 1? Give me 2 numbers that multiply to 17, but you can't use the number 1. Why not?
You just can't. There's not 2 numbers that will multiply to 17 without using the number.
17 is prime. 17 is not factorable. Can't break it apart. If you can't find 2 magic numbers, then one of 2 things. Either you made a mistake or no such numbers exist. Thus, it would not be factorable and you would not be able to continue. But let's say that you found those two magic numbers. Then you would need to organize your information into a T-chart, and I am going to show you that in the example. You would have to organize your information into a T-chart / simplify. If you were able to simplify, a lot of the time simplification just doesn't happen, but if you can simplify, you must simplify. And then ultimately, step 5 is just writing your factors. This is the complete Tucker method for factoring quadratics. No extra bells or whistles, no exceptions to the rule. This thing works. If it is factorable, if you have a quadratic that is factorable, this will work. Guaranteed. Yes. Here's the example, or one of the examples. 2x squared plus x plus 6. There we go. 2x squared plus x plus 6. Step 1 is to try and take out that greatest common factor, which in this case, the greatest common factor is what? I mean, they both have an x in common here, but not with all three. They both have a 2 in common here, but not with all three. What's the greatest common factor? I can hear crickets. Did I tell you about my killer cat? When cricket season rolls around, we'll find cricket body parts strewn throughout the house. Because our cat, during the nighttime, likes to hunt them down, but he doesn't like to kill them. He likes to rip off body parts and watch them crawl. Yes, it would be one. What an amazing transition. But I'm being serious about my cat, though. It's pretty sick. But the GCF is 1. So I move on to step 2. Step 2 is to multiply A times C. Well, what's A and C here? What are my A and C values? Okay, 2 times 6 is 12. Awesome, we're almost there. I have to find 2 magic numbers that multiply to 12 and add up to my B value. Well, first of all, just for the record, what is my B value? No, say again? Yeah, it's not the variable, it's the coefficient that's in front of it. Can you give me 2 numbers that multiply to, oh, that shouldn't have been a 1, I apologize. Let's change that 1. Let's change that 1. I'm going to make it a 7. I apologize, that should not have been a 1. Let's make it a 7. There we go. Now I fixed it. Can you give me 2 numbers that multiply to 12 and add up to 7? Yay! If I left it a 1, you would not be able to do it. Yeah, if I left it a 1, which is why I had to change it, because I wanted this one to be factorable.
If you left it a 1, it would like just not be possible, or just too dumb to figure it out.
The first one.
Okay.
It would not be factorable if I left it a 1. Yeah. I would never consider you guys dumb. Wow. 3 and 4. The next step, after I find those 2 magic numbers, is to organize that information into a T-chart. 3 and 4 right there. Now, this has been a long time. It has been a long time since we've seen something like this. But do you happen to remember what goes in the top of that T-chart? It has been many months. Ooh.
Wait, what is that?
It's been many months since we've done something like this, so I hesitate to ask, do you guys remember what we put at the top of the T-chart?
Um, um, is it or X? You put X and X squared?
Almost. It is a 2x squared that I have. And I am breaking that 2x squared up. Now, I could break up that 2x squared as 2x and 1x, or I could break it up as 1x and 2x, but I have no idea what to do. So, instead of trying to figure out the guessing game, no guessing, I'm going to put 2x and 2x in both of them temporarily. Whatever that a leading coefficient is the number that goes with it, and you can break up the x squared as an x and x, so it's 2x and 2x. But it's T-chart / simplify, meaning I have to simplify this stuff down. This 2 and 3, treat that 2 and 3, the ones that I'm pointing to, treat that 2 and 3 as a fraction. 2 over 3 does not simplify. But does 2 over 4 simplify? To what? Yeah.
As Mark Pearson, please come to the main office. As Mark Pearson to the main office.
It simplifies to a 1 over 2, as she said. Then finally, I am ready to write the factors. The factors here, if I were to do this one right here, would be a 2x plus 3. And if I were to do the factors here, it would be a 1x plus 2. These would be my factors. Now, like I said, it has been quite a while since we have done anything like this. This is just a small reintroduction to factoring. I am going to continue reintroducing factoring on Tuesday. But with the time that we have, I want to see what you can do. I have a practice quizzes that I would like you guys to knock out. Again, emphasis on the word practice. I want to see where we're at. What do you remember with this short review, this very short review that I have done at the beginning of this class period? So if you would, please have those Chromebooks ready to go, because we're about to knock out a quizzes. I'm going to, no, I don't want that code. I wanted to put, make sure redemption questions were on. Good. Let's show memes for fun. Good. All right, let's get this thing rolling. There's the code that I want you to use. Get logged on as quickly as humanly possible. So I would like to, again, this is wholly based on what you know and what you remember. For those of you in the live chat, you can see that code, but I am going to type in the number anyway into the live chat just so you can see it. Get yourself logged on as quickly as humanly possible. Yeah, I got the window open. They basically said, hey, We're not going to be able to turn on the air conditioning today, but make sure that you crack your windows. Because apparently they're set to a certain schedule. There are certain cooling towers that they're not going to turn on because they have to maintenance them before the season actually starts, and they weren't planning on maintaining them until spring break.
Do you like being a secret environment?
Huh?
Do you like being a secret environment?
Being at Barney has nothing to do with it. I just enjoy what I do.
No, but like under the school.
If you could teach at another school, would you?
I have taught at another school, and it was one of the worst experiences of my life.
They've already set up.
Believe me, there are worse places.
Well, yeah, I know that. I know you're thinking.
Where did you teach at a different school?
Northern Maryland.
Oh my God. Oregon's taught in Maryland too.
Yeah, I taught in Harper County. I taught in a ill-gotten, failed charter school called Restoration Academy. I loved the students. I hated the way that I was treated by the administration.
Why did it fail?
A lot of reasons. It's too long of a story. Yeah. Let's just say that when I came here, it was like, I don't even know. Kids are trying to tell me, oh, Mr. Markey, you don't even understand. This is Barnegat. This is Barnegat. I'm like, shut up. I grew up at Barnegat. You guys are nothing, compared to what I just came from. Anyway. Believe me, they always say the grass is always greener. People are like, oh, that's just Barnegat for you. Believe me, that's what everyone says about their own school. Everybody. Starting. If you haven't logged on, please make sure that you're logged on. The code will be at the top of the screen. Yeah. The code will be at the top of the screen if you didn't get it. Can you promise me a perfect score? Don't worry about the time. Even if the timer goes off, you can still answer the question. Oh. This is a heated race for the top spot. saying. Because remember, even though he got that one, there are redemption questions. Because you set it equal to 0. You get nervous.
Right, I think they're all the ones, like, I'm like, oh, they're inflation was no versus
Just for practice.
What's prime mean? What's prime?
Oh, prime is like the number 17. 17 can't be factored.
But that's what I was talking about before. If no such magic numbers exist, and you haven't made a mistake, then it should be prone.
I'm going to give you guys another minute or so to wrap this up, because I would like to take a look at a couple of the questions, depending on how the accuracy came out. All right, I'm going to wrap it there. I want to take a look at some of these just to kind of see where we're at, because this data is going to be incredibly helpful for me just to see where most of the gaps are from back in the factoring section. Sort by accuracy. None of them were red, so that's good. Oh, nice. Solve by factoring. Okay, so factoring with a leading coefficient of 5. Factoring with leading coefficient of 2. Okay, this is good. This is perfect. Oh, this is perfect information for me, just because to be able to see what the heck is going on here. Nice. Okay, so here's what I want to do. I saw at least 2 problems that I want to try right now. 2 problems that I want to show you right now. One of them being this one. I'll show you what I wrote down in just a moment. There we go. There we go. This problem, it says to factor completely. Now, what a lot of you may have accidentally done is you may have immediately jumped to the 3 times 15. But you tell me, what is the first step of the Tucker method? GCF, greatest common factor. In this case, the greatest common factor of this particular problem is a 3. So you have to take that 3 out, but then you must continue with factoring. My brand new A value is a 1. A times C is 1 times 5. Can you give me 2 magic numbers that multiply to 5 and add up to 6? Huh? Multiply to 5 and add up to 6? Because what you gave me is multiply to 6 and add up to 5. 1 and 5. Now, the thing is, with the t-chart, because this is now a 1x squared, it's a 1x and a 1x that goes in the t-chart, and a 1 and a 5 that go on the bottom. Nothing simplifies. 1 over 1 is just 1 over 1. 1 over 5 is just 1 over 5. So I end up with the following, but do not forget to bring that 3 down, because you told me that the 3 was my greatest common factor. Thus, it is a factor in the problem. If you look at the choices that they gave you here, they did try to troll you a little bit, and I can see it. Most of you did pick the correct answer, but a few of you did pick the other ones. We have to be very careful on that. Let me see. I wanted to just jump down to this bottom one real quick as the last problem I would like to cover today, the very last thing. 5x squared plus 13x plus 6 equals 0. It says to solve by factoring. My GCF is 1. A times C is 30. 2 numbers that multiply to 30. I could do 5 and 6, but nope, 5 and 6 add up to 11. I could do 15 and 2, but nope, 15 and 2 add up to 17. 10 and 3. They are my magic numbers. But look what goes in the top. It's a 5x and a 5x, which I have to simplify to become 1 over 2. Thus, it becomes x plus 2, 5x plus 3 equals 0, but they still want you to solve it. So you would have to set those equal to 0 and solve like it was algebra 1, and you would end up with the following answers: -2 and -3 over 5. Reminder, that major is due tomorrow. If you have not left a comment in the chat, please make sure that you do so. Otherwise, there's the bell. And I'll see you on Tuesday. Ah! Thank you, too.